Hello everyone. So as I was uploading the other examples, I realized always do it with vertical and horizontal translations, but I never showed you guys an example of when you just do a single translation. So I will show you an example of each. Okay. So again, I have x cubed minus 2, g of x equals x cubed minus 2. So my parent function, okay, it is just x cubed. Right, this one's a little easier to see just because, it's just right there and subtracted by a number. Okay, it's a little more difficult when there's coefficients and just stuff within that cubed. Okay, but this one's x cubed. So what is the general graph is going to look like this. Okay, so now we're going to talk about hk. Remember, h is the horizontal translation and k is the vertical translation. Okay, so h in this case, okay, remember, I don't need to put it. So, yeah, I guess I can still like g of x minus h. Remember that would be x minus h cubed minus 2. Okay, in this case, our h is just 0. Okay, and our k is negative 2. Okay, it is this right here. For the cube, so f of x, okay, remember, so we're going to write up the parent table. So this is going to be, remember, negative 8, negative 1, 0, 1, 8. Remember, we picked these values is because, never mind. I was thinking about the cubes, the cube root. Okay, this is obviously not a cube root, so give me 1 second here. But luckily, okay, these are my y values, so I'm just going to move them over. So I have negative 2, negative 1, 0, 1, 2. Okay, not the same color. Oh well. Okay, because remember, negative 2 cubed is negative 8, negative 1 cubed is negative 1, so on and so forth. Okay, but now what I want to do is I want to find the table for the g. Okay, so remember, same thing. So when you do that, you're going to look for x plus h and then y plus k. In this case, x plus h is just 0, so I'm going to leave this as x. Okay, and then for y plus k, it's going to be y minus 2. So for this x, there is no horizontal translation. So what does that mean? I just have to copy this down because x equals x. So negative 2, negative 1, 0, 1, 2. And y equals negative 2. So negative 8 minus 2 is negative 10. Negative 3, 0. Negative 1. Sorry, not 0. I told you guys, cannot subtract today, or cannot do math today to save my life. Okay, negative 2, and then this will be 6. Okay, let me steal a graph real fast. Okay, so when I graph this, I have negative 2, negative 10, negative 1, negative 3, 0, negative 2, 1, negative 1, 2, 6. Okay, remember our general shape is like this snaky thing. What I usually like to do is I like to go to the center first and then draw this. Okay, doesn't matter how you draw it, just whatever helps you get to your final goal. Oh my gosh, it's getting worse. It's fine. Okay, but yeah, but still, as you can see, it still looks like a general snaky shape. Drew it to the best of my ability. Right? So again, just to prove to you, so I'm going to take this vertex, okay? Remember, so we're not going to go left or right, okay, because h is 0, but we're going to go down 2. And as you can see, this is right here. And this is the third point, because there's 2 over here and 2 over to the right. Right? So that is how you do if you just have a vertical translation, okay? But let's do another one. Okay, so 2, let's say, I don't know, h of x, and we'll call this x, x minus 2 cubed. Okay, again, the parent graph is just x cubed, and it looks like a snake. In this case, my h is 2, and my k is 0. Right? Remember, the horizontal shift is the one that is not intuitive. You take the opposite. And k is 0 because there's no vertical shift. So let me add some space here. Oops. All right. So I'm just going to copy this. So this is exactly the same. Okay, so I'm just going to copy and paste. And what I'm going to do, so I have, it's going to be x plus 2, and then y. Remember, again, we have this x plus h, y plus k, so x plus h is x plus 2, y plus k is y plus 0, y plus 0 is just 0. Oh my goodness, y plus 0 is y. And it's just so sad, guys, because I feel like I'm messing up like the most basic one. It's 0. It's like, ugh. Okay, bear with me. So what we're going to do, so for y plus 2, or x plus 2, so it's negative 2 plus 2 is 0. And this is 1, 2, 3, 4. Okay, and then for the y's, we're just going to keep it the same. Negative 8, negative 1, 0, 1, 8, because y equals y. Okay. Getting tired of green, so I'm just, actually, you know what I'm going to do? I can make it look like an Oompa Loompa. So I'm going to choose orange. Alright, so I have 0, negative 8, 1, negative 1, 2, 0, 3, 1, 4, 8. Again, drawing this general shape, okay, to the best of our abilities. Right? I think it would be good to see, probably for both of them, I should have done the graph. So, okay, this is what I'll do. So, in black, I'm going to graph this. Okay, so I have negative 2, negative 8, negative 1, 0, 0, 1, 1, 2, 8. Okay, and I'm going to represent it by little dashes. Okay, so as you can see, still the same shape, because remember these are rigid transformations. Okay, it does not change. It just, all you do is you take that graph and we're just moving it around. So if I took this graph, I could have literally copied and pasted it, or copied it and then pasted it where x is equal to 2. Okay, with this middle point right here. Right, so as you can see, the same thing, we just moved it over to the right 2. Right, same thing goes for here. Okay. 1 second. Right. Kind of drawn a little rough, but it's fine. But as you can see, still, what we do is still the general shape, still same thing. It's not, was not conformed in any way. We just took this graph and we just shifted it down 2. Right, and this is how you graph when you are just given one translation. So you just keep that particular coordinate that that does not have the translation.